Hi everyone, Notes 3.2 are on lines of best fit, and we're going to do an investigation, and it shows here a table that shows data for a beach during 2 weeks in July, and we're going to do our line of best fit in Desmos. So if you notice here, we've got high temperature and estimated number of people, and really quickly I just want to talk about which one's the independent variable and which one is the dependent variable. High temperature here is the independent variable, and the dependent variable is the estimated number of people because the number of people depend on what the temperature is going to be that day, right? Like if I'm going to go to the beach, I'm going to want to go to the beach on a hot day. So my trip to the beach is dependent on what the temperature is that day. And so even though the questions are listed in these notes here, they're actually also in the Desmos link right here. So I'm going to go straight to the Desmos link, type in all of my data, and then go from there. So here I have my data, so I'm just going to type in all of my numbers. And just a reminder that the x-axis here represents the high temperature and the y-axis here represents the estimated number of people. So let's go ahead. I'm just going to maximize the screen now. And I want to talk about how we can adjust this so we can see it. We can't see any of these points right now because the points are large numbers. These numbers are in the 20s and the 30s. We've got one in the teens right here. And these numbers are in the hundreds, right? And this x-axis only goes out to 10 and the y-axis only goes out to a little bit above 6. So what I would do is I would press this graph settings button, this wrench button that I see here, and I want to label my x-axis first of all as temperature, and it was in degrees Celsius. Okay, and I want to label my y-axis as estimated number of people. Okay, but for my x-axis here, I can see that my smallest x value here is 19 and that my largest x value, I believe, is around 36. So I need to reflect that in my graph settings here. So I'm going to go a little bit below 19, so I'll go to 15, and I'm going to go a little bit above 36. I'm going to try to go to like 40. I still can't see any of my values, even though my x values are covering these x values here. My y values are still too low on my graph to see these large y values. So it seems like my lowest y value that I see here is 180, and it appears that my largest y value appears to be around 480. So I'm going to go a little bit below 180 for my y-axis. So I'm going to say let's go from like 150 to about, I don't know, 500. I'll even go higher than 500 just so I can see what's happening with my graph here. So as you can see, this is what my graph looks like. And you can also zoom in, zoom out, okay? And you can also move your graph as well. Okay, so we've got our data in here. So let's look at our instructions. It says create a scatter plot to show the relationship between temperature and the number of people who visit the beach. We've gotten that. Make sure to label the axes. So we've labeled the temperature here and our estimated number of people here, and adjust the scale properly. We've done all of that. Now the next thing we need to do is to describe the trend in the data. So I can see it's very clear to me that it has a positive trend. As the x values are increasing, the y values are increasing. And I can see that by the fact that my graph is going up from left to right. And this should make sense because as the temperature is hotter, the more people will visit the beach, right? So this has a positive correlation. As the temperature increases, the estimated number of people visiting the beach also increases. As the temperature decreases, the estimated number of people visiting the beach also decreases. They're both moving in the same direction. As one goes up, the other goes up. As one goes down, the other goes down. All right, awesome. So we're done with the instructions part 1. Okay, so now we want to draw a line that will A, pass through the first and our last points. So here's our line and it's draggable, okay? So I can drag my line so that it goes through my first and my last points. So here, this is my first point right here, and I would say maybe this is my last point right here. And so this is what we did. Part A is done in our orange line, okay? Part B says passing through the middle point 28,360 and as close to the first and last points as possible. So this one's going to be our purple line. So let's see what that's going to look like. So here, it has to pass through the point 28,360. So here I'm going to go to 28 and then I'm going to find where 360 is, which is approximately right here because it's a little bit more than halfway between 300 and 400. So I'm going to drag one of my points to that point right there. And then I'm going to drag my other point so that it is as close as possible to the first and last points that we have here. So I will try to make it look more like this maybe. Okay, so here's our second option for a line of best fit. And by the way, a line of best fit is literally a line that best fits the data, okay? The best line to represent this data. All right, so now let's look at choice C for another type of line we could draw. Passing through as many points as possible with about half of them above and half of them below your line. So let's drag this so we can play around with it a little bit. I wanna go through as many points as I possibly can, okay? And obviously it's not gonna be possible to go through every single point, but I want to go through as many points as I possibly can with half the points above the line and half the points below the line. And this is tricky. This can get really hard right here. So let's have it maybe like this right here. So if you can see here, I've gone through about 2 points and I have 1, 2, 3, 4, 5, 6, 7 points above the line and I have 1, 2, 3, 4, 5 points below the line. So 7 to 5 is not exactly half and half, but we're getting closer to half and half. What if I were to move this like this instead? So now let's count how many points are above the line. So 1, 2, 3, 4, 5, 6 points above the line. And then I have 1, 2, 3, 4, 5, 6, 7 points below the line. This is looking a little bit better. So now let's look at what we have here. I adjusted it a little bit more, right? So we have 2 points right here that have gone through the line, and I have 1, 2, 3, 4, 5, 6 points below the line and 1, 2, 3, 4, 5, 6 points above the line. So this looks like I've got half of them above and half of them below, and I think that's as close as I can get when it comes to the line going through as many points as possible. So now let's compare our 3 lines and see which one seems like the best representation for what a line of best fit is. So let's look at our first one that we had, passing through the first and last points. This is not a good line of best fit because all the points are above this line right here. If I were to use this line to predict some other data, my answers would be too low because all of these values here are above this line right here. Let's look at the one where the line went through the middle point right here. It's a little bit better, but there's still too many points above the line right here. And that's why our best choice is this one right here, where we try to get it to go through as many points as possible with about half of them above and half of them below. But if you notice, these two are pretty close to each other. Okay, all right, so we're done drawing our line. So let's just extend this information right here. So it says to extend the best line or the line of best fit and use it to predict the estimated number of people at the beach when the temperature is 40 degrees. So here, I want to know when the temperature here is 40 degrees, approximately how many people will be at the beach? Well, the temperature represents the x value. So I'm literally going to write x equals 40 in my graph right here. And I can see that it intersects right here at 588. So approximately 588 people will be at the beach when the temperature is 40 degrees Celsius, right? And then the next question says to estimate the number of people at the beach when the temperature is 20 degrees Celsius. So here our temperature is still x, so I'm going to say x equals 20, and we would expect about 220 people at the beach. So we can say approximately 200 220 people will be at the beach when the temperature is 20 degrees Celsius, which makes sense. The hotter it is, the more people we'll have. The colder it is, the less people we have. And that's what a line of best fit is. That's how you find it, and that's how you use it to help you answer some questions and predict some answers. Okay?